Aim of the experiment: to study the thermal decomposition of ammonium chloride in an open container. Theory: chemical compounds such as ammonium chloride, when heated in an open container, is decomposed into its constituents hydrogen chloride and ammonia in their gaseous states. This is an example of a type of chemical reaction known as decomposition reaction. However, an interesting aspect of the thermal decomposition of ammonium chloride is that it is a reversible reaction. When heated, ammonium chloride is in equilibrium with ammonia and hydrogen chloride. When these two breakdown products reach a cooler region of the reaction vessel, they quickly recombine to form solid ammonium chloride. So the reversible decomposition reaction of ammonium chloride can be considered as decomposition reaction coupled with combination reaction. Because of this very property, the interesting thing about the thermal decomposition of ammonium chloride is that it can also be considered as a form of physical change called sublimation, and is in fact a common classroom demonstration for the process of sublimation. Sublimation is a physical process wherein a solid substance directly converts to its gaseous state without going through its liquid phase. It is considered a physical change because it only involves a change in the state of the matter without any alteration in the chemical state of the substance. Materials required: solid ammonium chloride, spatula, forceps or tongue, a piece of cotton, Nessler's reagent, blue litmus paper, a strip of filter paper, tripod stand with wire gauge, spirit lamp or a Bunsen burner, china dish, and a glass funnel. Procedure: take a spatula full of ammonium chloride in a clean and dry china dish. Place a clean and dry funnel inverted over the china dish. Plug the open end of the funnel stem loosely using a piece of cotton or glass wool. Place the china dish on a wire gauge on a tripod stand. Once the setup is ready, begin heating the china dish. Record your observations. Observations: after a couple of minutes of heating the ammonium chloride, you will observe copious amounts of white fumes begin to form and occupy the inside of the funnel. The ammonium chloride salt also begins to disappear slowly and turn directly into a gaseous phase without any intermediate liquid phase. Meanwhile, throughout the inner walls of the funnel, which is comparatively cooler than the porcelain dish which is being heated, thick white deposits can be seen forming. At this point, if you remove the cotton plug from the funnel stem and bring a strip of filter paper moistened with Nessler's reagent, you will observe that the filter paper strip turns yellowish brown as it comes in contact with the white fumes released from the funnel stem. Also, if you bring a strip of moistened blue litmus paper, the litmus paper gradually turns red. At the end of the reaction, you can see that all the solid ammonium chloride crystals in the china dish had disappeared and are completely deposited as white residue on the inner walls of the funnel and even on the sides of the porcelain dish. Results and discussion: the reversible thermolytic decomposition of ammonium chloride is represented by the chemical equation shown here. The gaseous phase formed by heating solid ammonium chloride is actually a mixture of ammonia and hydrogen chloride gas. It is worth noting here that the gas formed is not ammonium chloride in vapor phase. As the mixture of ammonia and hydrogen chloride gases reach the cooler parts of the funnel, they chemically recombine to form solid ammonium chloride again, which is seen as white deposits on the inner walls of the funnel. The fact that the fumes released are initially composed of basic ammonia gas and acidic hydrogen chloride gas is demonstrated by the Nessler's test and the litmus test. Nessler's reagent test is a highly sensitive test for the presence of ammonia. A positive Nessler's test is reflected by the change in color of the reagent from colorless to a yellowish-brown color. We saw that the filter paper dipped in Nessler's reagent turned yellowish-brown, thus confirming the presence of ammonia in the white fumes released. Blue litmus paper turns red in the presence of an acid. In our test, we saw that the blue litmus also turned red as it came in contact with the white fumes. The only plausible explanation for this, considering the circumstance, is that the white fumes contained hydrogen chloride gas, which is highly acidic and was able to turn the blue litmus red. As both the decomposition products of ammonium chloride reached the cooler parts of the funnel, they chemically recombined to form white solid ammonium chloride, which are the white deposits found on the inner walls of the funnel and the china dish. The reversible thermolytic decomposition of ammonium chloride is thus a special type of reaction that bears the hallmark features of decomposition reaction in the initial stages but becomes a combination reaction in the later part of the reaction.